On November 7, 2025, tracking data from both the Solar Orbiter and the Mauna Kea Observatory confirmed a development no one wanted to see. The interstellar object known as 3I Atlas, now at its closest approach to the Sun, is slowing down, not just a marginal deviation within instrumental error, but a measurable, consistent reduction in heliocentric velocity. The numbers began diverging 3 days ago, small enough to dismiss as solar wind interference, until the pattern held. The deceleration isn't chaotic, it's smooth, deliberate, and mathematically coherent. Instead of accelerating as it falls deeper into the Sun's gravitational well, the object has begun shedding velocity in a controlled manner, as though opposing the very force drawing it in. For observers, it's a physical impossibility that feels almost intentional. Solar radiation pressure, outgassing, drag. None account for the precision of the slowdown or its stability across observation frames. Across research networks, the tone has shifted from curiosity to quiet concern. Analysts have started cross-referencing earlier anomalies, the rhythmic oscillations in its light curve, the stable temperature profile, to determine if all of this was leading to this point. As one researcher put it in a private note, the object isn't behaving like debris, it's behaving like it knows where it wants to be. The question now is whether the slowdown is an external response, an interaction with the solar environment, or something intrinsic to 3I Atlas itself. Whatever the cause, the data have reached a threshold where coincidence no longer feels adequate. And that's where this story begins. At the moment when our equations stop explaining what's in front of us, and something unprecedented emerges from the noise. The earliest indication of orbital drift came from the European Space Agency's Solar and Heliospheric Observatory, which had been monitoring 3I Atlas for over 4 months. Its predictive models, refined daily through continuous telemetry, began showing a mismatch in the object's projected path. The discrepancy was small, fractions of a degree in angular momentum, minor deviations in perihelion distance, but consistent across independent measurements. The data suggested that the object's trajectory was subtly diverging from what gravity alone would dictate. At first, astronomers attributed the variation to incomplete modelling of the solar corona. The Sun's outer layers are turbulent, filled with dense plasma streams capable of distorting readings. But as more observatories joined in, NASA's STEREOA, Japan's Hinode, and even ground-based instruments in Chile and Hawaii, the drift persisted, revealing an unambiguous trend. The object was not only slowing down relative to the Sun, but adjusting its orientation in minute, regular intervals. Each recalibration effort failed to eliminate the anomaly. When teams reprocessed the data using different solar wind models, the deviation returned, unchanged. What made this particularly unsettling was its precision. Natural perturbations are erratic, they fluctuate in strength and direction, yet 3I Atlas appeared to resist those fluctuations. The slowdown curve was almost linear, a perfect counter-gradient to gravitational acceleration. Astronomers at the Harvard-Smithsonian Astrophysical Observatory ran a parallel simulation using real-time solar field maps. They found that even after correcting for every known physical influence, solar tides, radiation pressure, possible dust interactions, the residual deceleration remained. It was as if an invisible hand had applied a gentle but deliberate brake. Some attempted to revive older explanations used for Oumuamua, like asymmetric outgassing, jets of vapour from sublimating ice acting as thrusters. But 3I Atlas displayed no such behaviour. Its albedo readings, thermal emissions and spectroscopic data showed no traces of venting activity. Even the James Clerk Maxwell telescope, operating in sub-millimetre wavelengths, found nothing that could account for thrust. By now, the anomaly had captured the full attention of the astronomical community. Every model that tried to fit the observations failed to preserve consistency beyond a few days. It wasn't just about the slowdown, it was about coherence. 3I Atlas behaved with a kind of internal logic, as though responding to parameters we didn't yet understand. The working groups began to divide into 2 camps. One insisted that undiscovered natural processes, perhaps magnetic drag from charged solar particles or a unique structural composition, were at play. The other hesitated to call it mechanical, but admitted the data behaved as if the object possessed internal regulation. No one dared use the word artificial in formal reports, but in private discussions it surfaced again and again. By the first week of November, orbital drift had become impossible to dismiss. Calculations placed the velocity reduction at roughly 2% compared to projections, a massive shift in cosmic terms. When plotted over time, the graph looked disturbingly intentional, a steady flattening of what should have been a downward curve. And yet, if the slowdown were merely the product of a physical process, it had to leave a signature somewhere, a measurable consequence, a visible effect. That evidence, however, had yet to appear. As one mystery deepened, another began to surface in the data. Photometric readings, taken simultaneously from multiple instruments, started showing irregularities in a light intensity that did not correspond with simple reflection or rotation. The irregularities in light reflectivity began as faint noise, minor dips and rises within a few percentage points of the baseline flux. But their consistency was impossible to ignore. Every rotation of 3i Atlas produced a repeating, almost rhythmic pattern. Unlike the chaotic flickering of a tumbling rock, these pulses appeared coordinated, as though modulated by some process responding to external conditions. At first, photometric teams suspected a rolling surface irregularity, perhaps an uneven albedo caused by dust or metallic fragments. But deeper scrutiny from NASA's infrared telescope facility revealed that the pattern persisted even when the object's phase angle changed. This meant the variation wasn't just about sunlight hitting different faces, it was intrinsic. The amplitude of the pulses correlated weakly with the object's distance from the Sun, suggesting some interaction with solar radiation, yet the frequency remained constant. When researchers converted the light curve data into frequency spectra, a distinct peak emerged around 27 minutes, a precise cycle that had been noticed weeks earlier, but was now showing subtle modulation. The pulse frequency began splitting into harmonics, forming secondary peaks at half and double intervals. In nature, such clean harmonics rarely occur without resonance or deliberate synchronization. The light oscillations were accompanied by minor shifts in polarization, hinting that magnetic fields could be involved. This led scientists to consider a startling possibility. The brightness variations might not be purely reflective but emissive, light generated or filtered by some material process on or within the object. If 3i Atlas contained regions capable of emitting controlled thermal or plasma discharges, the effect could resemble a coded flicker rather than random reflection. The European Southern Observatory compared these fluctuations against known plasma emission patterns from charged cometary tails. Nothing matched. Even when modelled under extreme solar wind conditions, the predicted output failed to reproduce the precision of the observed signals. The stability of the periodicity suggested a feedback mechanism, something adjusting itself in real time. Meanwhile, solar monitoring instruments detected brief electromagnetic fluctuations each time the object's luminosity peaked. The correlation was small but statistically clear. The object seemed to be coupling with the solar magnetic environment, drawing and releasing energy in rhythmic pulses. Such interaction requires conductive or magnetically responsive material, properties rarely sustained by interstellar debris after such long exposure to radiation. Thermal sensors added another layer to the puzzle. Despite the intense proximity to the Sun, the object's infrared emissions showed a remarkably steady temperature profile, varying far less than any natural body under similar conditions. No known composition, not even carbonaceous or metallic, could maintain that kind of equilibrium without active regulation or unusual surface properties. The pattern became the central mystery in every observatory's nightly review. Some astrophysicists began to frame it as dynamic modulation, a neutral term that avoided implying control while acknowledging the precision. The word control, however, lingered in private discussions. If 3i Atlas was capable of moderating its own output, thermal, magnetic or otherwise, then the definition of object itself would need reconsideration. Still, caution dominated official discourse. Papers submitted to major journals emphasized non-anthropogenic explanations, resonant cavities, magnetic drag, induced currents from plasma sheath interactions. These mechanisms were complex but theoretically possible, yet every proposed model required fine-tuned parameters that existed only within narrow ranges of density and charge, ranges too specific for a naturally ejected interstellar body. The light curve irregularities soon reached a level of significance that could no longer be classified as instrumentation noise. The synchronized pulses, the thermal constancy, and the accompanying magnetic correlation all converged on one conclusion. something about 3i Atlas was interacting with its environment in a way that defied passive behaviour. As analysts worked through these results, one question began to surface across internal reports and encrypted emails between observatories. Was the slowdown, the deceleration now measured beyond any reasonable doubt, directly linked to this modulation? If so, then 3i Atlas might not simply be slowing down, it might be adjusting itself, and to understand that possibility, researchers turned toward the one field capable of providing clues: the study of solar plasma and magnetic coupling, where energy, motion, and light can intertwine in ways that blur the line between matter and mechanism. The transition from optical irregularities to magnetic correlation came naturally, almost unavoidably. As observatories synchronized their monitoring systems, they began noticing something that had escaped initial analysis. Each light pulse from 3i Atlas coincided with a faint, localized fluctuation in the solar magnetic field. It wasn't strong enough to disturb other nearby readings, but its timing was exact, repeating every 27 minutes, matching the rhythmic oscillations seen in the light curve data. At the European Space Operations Centre, magnetometer data from the solar orbiter showed minute variations in field strength, barely measurable, yet too consistent to be random noise. Each magnetic shift corresponded precisely to a brightness change recorded by telescopes on Earth. The synchronization spanned millions of kilometers, eliminating any chance of data overlap or coincidence. To the scientist reviewing these datasets, it looked as though 3i Atlas was responding to the Sun's magnetic structure, or possibly influencing it. When NASA's Parker Solar Probe crossed a region of dense plasma filaments, it detected weak but rhythmic perturbations travelling through the heliospheric current sheet. Analysts described them as ripples, micro-distortions moving outward at predictable intervals. Tracing their origin pointed directly toward the coordinates of 3i Atlas. Nothing like it had been observed before. Magnetic interactions between natural bodies and the solar field usually produce chaotic signatures, not discrete repeating waves. The pattern raised the question: was 3i Atlas generating these oscillations itself, or was it merely amplifying existing fluctuations within the solar wind? If the latter, then its material composition must include elements capable of high conductivity resonance, possibly metals arranged in layered or crystalline forms. But if the former was true, if the object was producing the magnetic shifts autonomously, that would imply an internal system capable of regulating current or charge across its surface. To test this, researchers compared data from multiple spacecraft: the Parker Solar Probe, Solar Orbiter, and even Japan's Akatsuki satellite positioned near Venus's orbit. All detected traces of synchronized field behavior pointing toward the same source. The amplitude was small, but the coherence, its mathematical regularity, was absolute. In physics, coherence implies order, and in nature, order of this kind rarely sustains itself without feedback control. By this point, the conversation inside research teams had grown careful, almost coded. Reports used neutral phrasing, phase-locked oscillations, magnetodynamic coupling, external coherence phenomena. Behind those terms lay a shared unease. The object's behavior was beginning to look less like a passive traveler through the solar system, and more like something engaged in an active process, perhaps stabilizing, perhaps testing its limits within the Sun's gravitational field. The possibility of magnetic braking emerged as the leading conventional hypothesis. If 3i Atlas carried a highly conductive structure, interactions with the solar magnetic field could generate opposing forces that act as a decelerating torque. Similar mechanisms had been theorized for artificial sails and magnetic drag devices used in conceptual space engineering. Yet the calculated energy requirements didn't align. For a body of its estimated mass, the observed slowdown exceeded what magnetic drag could achieve by several orders of magnitude. The next layer of inquiry focused on correlation between these electromagnetic pulses and changes in thermal emission. Here the results were even stranger. Each pulse corresponded to a microscopic dip in surface temperature, as if energy was being absorbed rather than emitted. A body approaching the Sun should heat continuously, especially when exposed to intense flux. Instead, 3i Atlas seemed to regulate itself, maintaining near constant temperature while performing what looked like controlled energy exchanges. Spectrographic readings added yet another piece to the puzzle. During each pulse, narrow absorption lines appeared in the near-infrared spectrum, temporary, faint, and unlike any known chemical signature. The lines suggested interaction with magnetic fields at the quantum level, perhaps involving transitions within exotic compounds or alloys. Whatever the composition, it did not behave like ordinary rock or ice. These findings forced scientists to revisit prior assumptions about its origin. If 3E Atlas had been ejected from another star system, it might carry materials unknown to our periodic framework, capable of superconductive behavior even under extreme heat. That could explain the coupling, though not the precision or apparent intentionality behind the pattern. The working theory became cautious yet astonishing. 3I Atlas might possess an adaptive outer layer, something that senses and adjusts to electromagnetic pressure. Whether that adaptation is biological, mechanical, or purely material remains uncertain. What is certain is that every measurable property of this object contradicts the randomness expected from cosmic debris. And as more instruments began registering faint harmonics resonating through the heliosphere, a deeper concern emerged. The oscillations weren't merely confined to the object's immediate surroundings, they were propagating, faintly echoing outward, like a signal travelling through the fabric of the solar field itself. If the slowdown truly originated from magnetic interaction, it was no longer just a question of motion, it was a question of intent, or at least of purpose embedded in design. And for the first time since its discovery, the name 3I Atlas began to appear not only in astronomy journals but in closed-door defense briefings. Because the more scientists tried to describe it, the less it resembled anything nature had ever made. At Harvard-Smithsonian, the realization came quietly but unmistakably. After weeks of speculation, cross-verification, and statistical correction, the slowdown was no longer a question of measurement error. It was a verified, reproducible event. 3I Atlas had, beyond any doubt, decelerated near the Sun. Every dataset, optical, spectroscopic, and magnetics, converged on the same conclusion. The orbital path was flattening where gravity should have steepened it. The confirmation arrived in layers. Harvard's optical telemetry, running continuous photometric tracking since mid-October, showed a cumulative velocity loss of several meters per second per day, far exceeding any plausible drag or dust interference. The European Southern Observatory independently verified the trend using Doppler spectroscopy, while NASA's Deep Space Network provided radar data that aligned perfectly with both. The conclusion was inescapable. 3I Atlas was actively resisting the Sun's gravitational acceleration. Inside the Center for Astrophysics, a conference call convened late into the night. Harvard analysts shared their findings with teams from Caltech, ESA, and the Institute for Astronomy in Hawaii. The tone was restrained, professional, but under the surface, disbelief ran deep. They'd seen anomalies before, light curves that defied rotation models, trajectories skewed by outgassing, but nothing that sustained such consistency under this level of scrutiny. A graduate researcher, reviewing the combined graphs projected across the meeting room, described what everyone was thinking, but no one wanted to voice. The deceleration profile wasn't random. It mirrored the shape of an active feedback curve, the kind produced by control systems when they regulate input and output dynamically. The suggestion hung in the air for a long moment before someone redirected the conversation toward nonlinear plasma interactions. The official terminology stayed cautious. Reports labelled the phenomenon as dynamic modulation within gravitational parameters, a phrase that meant everything and nothing at once. But within closed groups, the private hypothesis was bolder. 3I Atlas might be an energy-regulated structure. Researchers revisited archived data from its earlier trajectory, searching for precursors of this behaviour. They found subtle hints, microfluctuations in brightness, faint oscillations in its speed relative to background stars, patterns that, in retrospect, seemed like precursors to the current deceleration. If the object had been adjusting its motion incrementally since entering the inner solar system, then this slowdown wasn't a reaction. It was the final stage of a plan. Still, the scientific method demanded restraint. The teams dissected every possible natural cause. Could a dense magnetic field within the solar corona induce such an effect? Could charged plasma accumulation along its surface act like a brake? The models failed. Magnetic drag could account for minor deflections, not sustained deceleration on this scale. Solar wind pressure was too weak. Outgassing was non-existent. The physics didn't fit. Meanwhile, thermal infrared data continued to perplex analysts. The object's temperature remained stable within a few degrees despite intense solar exposure. This constancy, coupled with the measured slowdown, implied an internal energy exchange mechanism, one that absorbed, redistributed, or emitted energy with near-perfect efficiency. On Earth, such equilibrium would require active regulation, not passive matter. At the European Space Operations Centre, one senior scientist proposed an unsettling analogy. What they were seeing resembled a spacecraft performing a gravity counterburn, except no engines, no thrusters, and no propellant had ever been observed. The reaction was silence. They all knew the word spacecraft carried implications that no institution was ready to endorse. Instead, the discussion shifted toward precedent. Oumuamua had exhibited non-gravitational acceleration, though faint and short-lived. Borisov, the second interstellar visitor, behaved predictably, purely cometary. But 3I Atlas defied both categories. It combined the reflective stability of a metallic body with the non-thermal behaviour of something operating under control. By November 7th, the data package compiled by Harvard and ESA had been sent to NASA headquarters for review. The report's language was clinical but heavy with implication. Object 3, I-Atlas, exhibits sustained non-gravitational deceleration, inconsistent with known physical processes. Continuous monitoring recommended the document would soon circulate among agencies beyond astronomy, those tasked with planetary defense, signal intelligence, and space situational awareness. Because at its core, the question had shifted. It was no longer just about what 3I Atlas was made of. It was about what it was doing. And as observatories prepared for another night of measurements, one uncertainty grew larger than all others. If the slowdown continued at this rate, 3E Atlas would soon stabilize into a near-stationary solar orbit, something no interstellar body has ever done before. If that happened, the narrative would change from scientific anomaly to something far stranger. An object that had entered the solar system, approached the Sun, and chosen to stay. By the end of the first week of November, what had started as a technical curiosity was quietly transforming into one of the most heavily scrutinized scientific events in recent history. The slowdown of 3I Atlas was no longer theoretical. It was a real, physical phenomenon backed by converging datasets from more than a dozen independent observatories. But confirmation only deepened the mystery. Every new measurement seemed to eliminate one explanation and expose two more. At NASA's Jet Propulsion Laboratory, orbital analysts ran time-synchronized simulations to project where 3I Atlas should be if it were purely under gravitational control. The resulting trajectories diverged from the observed path by tens of thousands of kilometers, an error far too large to attribute to solar radiation pressure or unaccounted mass. The consensus among mission directors was stark. Something external or internal was applying force to the object. But the mechanism remained invisible. ESA's solar orbiter began detecting narrow structured perturbations in the surrounding plasma density near the coordinates of the object. These disturbances behaved like transient bubbles of pressure moving outward from 3I Atlas at uniform intervals, consistent with the earlier magnetic oscillations. In plasma physics, such precision is unknown outside laboratory confinement fields. It was as though the object carried its own magnetic envelope, stabilizing itself against the violent solar environment. Meanwhile, NASA's Goddard Space Flight Center reviewed thermal data yet again. Their infrared sensors, normally used to track heat dissipation across asteroids, returned readings so stable they bordered on impossible. 3I Atlas, bathed in solar radiation intense enough to vaporize most materials, retained an equilibrium temperature within a 2-degree margin for over 72 hours. If the slowdown were linked to this thermal stability, the object could be converting absorbed solar energy into another form, perhaps kinetic regulation. In engineering terms, that would imply active energy management. These findings began to reach institutional command levels outside the scientific community. The Planetary Defense Coordination Office, typically concerned with impact risks, was quietly briefed on the trajectory data. The slowdown meant 3I Atlas was not on a collision course, but that fact made the behavior even more unusual. Instead of passing through the inner system and continuing on its way, as every interstellar object before it had done, it seemed to be preparing to remain. As data accumulated, research centers began to notice an additional feature buried in the electromagnetic spectrum, a narrowband emission near 1420 MHz. That frequency, corresponding to the hydrogen line, had long been used in radio astronomy and SETI protocols because of its universal cosmic significance. The emission was faint, intermittent, and always appeared within minutes of the object's deceleration phases. To some, it looked like an artifact of solar interference. To others, it resembled a signal, a natural resonance perhaps, but one whose timing defied coincidence. The Harvard-Smithsonian team resisted interpretation. Their official statement described the reading as hydrogen line fluorescence, but privately, analysts debated the odds of random alignment across so many parameters. The modulation, though weak, carried a consistent envelope pattern, 5 minutes of activity, then complete silence, then a repeat cycle matching the light curve oscillations. No known natural source produces that rhythm while maintaining thermal and magnetic coherence. The response from the broader scientific community was cautious, even defensive. Many urged restraint, reminding that extraordinary claims demand extraordinary evidence. But the pressure was growing. Major observatories were now competing to publish first, and agencies were being forced to coordinate real-time data sharing, an uncommon move for international missions. The race to explain 3-eye Atlas had become a global endeavour. Outside public view, select departments began modelling what might happen if the slowdown continued. The results were alarming. If the rate of deceleration remained stable, 3-eye Atlas would reach near-zero heliocentric velocity within weeks, effectively halting relative to the Sun. In celestial mechanics, such an event borders on impossible without constant thrust or controlled field manipulation. Natural bodies cannot stop, they can only orbit or fall. The scenario forced scientists to rethink the framework of motion itself. Could electromagnetic interaction with the solar wind create a localized equilibrium point? Could internal magnetic fields generate a counterforce to gravity? Theoretically, yes, if the material had conductivity levels beyond anything known in natural astrophysics. By November 7th, a pattern had emerged that unsettled even the most cautious voices. Each slowdown interval coincided with a measurable magnetic pulse, a brief hydrogen line emission, and a corresponding stabilization in temperature. The three signals rose and fell in unison, as if controlled by one integrated process. At this point, Harvard's lead data analyst proposed an extraordinary but testable hypothesis. What if 3-eye Atlas wasn't resisting gravity at all, but responding to it? In other words, what if the object was using the Sun's gravitational pull as a reference point, adjusting its own motion through feedback loops we didn't yet understand? If that were true, then the deceleration wasn't arbitrary. It was intentional, dictated by a set of physical principles far beyond our current engineering capacity. And if it could control its momentum this precisely near the Sun, then its purpose here, whatever it was, had only just begun to reveal itself. At the European Southern Observatory, dawn arrived with a sense of unease rather than excitement. By then, 3-eye Atlas had defied enough physical models to exhaust the patience of even the most disciplined scientists. Yet no one dared to speculate publicly. Every new observation tightened the boundary between acceptable science and the unknown, and few were willing to step beyond it. The latest datasets from Solar Orbiter revealed something entirely new. The deceleration of 3-eye Atlas was not uniform. It occurred in discrete stages, pulses of slowdown lasting roughly 27 minutes, separated by intervals of near-constant motion. When mapped against its light curve and magnetic oscillations, the timing aligned almost perfectly. The implication was staggering. The object wasn't simply drifting, it was regulating its movement in cycles. Inside a dim control room at Harvard, researchers replayed the telemetry again and again. The data looked like a heartbeat. A smooth acceleration curve tapering into a flat line, followed by another pulse, each identical to the last. When smoothed into a continuous plot, the pattern resembled a biological rhythm more than a mechanical function. Some joked nervously that the object was breathing, but the silence that followed those remarks lingered too long. Spectroscopic scans deepened the mystery. During each slowdown phase, 3-eye Atlas's spectral signature shifted slightly toward the red, not from velocity change alone, but from what looked like an intrinsic alteration in emission profile. The object's reflected light dimmed marginally, while the narrow hydrogen line signal strengthened. Then, as motion resumed, the pattern inverted. It was as if 3I Atlas absorbed solar energy during deceleration and released it afterward, a process completely inconsistent with inert matter. At NASA's Goddard Space Flight Center, analysts began modeling the effect as a form of resonant magnetic braking, similar to how electromagnetic sails might one day decelerate spacecraft without fuel. But the forces required here were astronomical. To counter the sun's pull at this distance, the magnetic field strength needed would rival that of entire planetary magnetospheres. No known natural mechanism could generate such stability over hours without collapse. Meanwhile, Japan's Hinode Observatory recorded fine structures forming briefly in the solar corona around the object, wisps of ionized plasma curving as though shaped by invisible boundaries. These arcs appeared during each deceleration pulse and dissipated immediately afterward. In raw composite images, the arcs outlined a faint symmetrical pattern surrounding 3I Atlas, something like a field envelope or magnetic bubble. It looked engineered, though no one could explain how. The international research community was reaching an inflection point. Publicly, official statements remained cautious. Further study is required. Privately, communications networks between observatories buzzed with encrypted exchanges. Physicists from Cambridge and Kyoto proposed that the object might host a superconductive shell interacting dynamically with solar flux, creating an induced drag effect. Others suspected a phase change material unknown to terrestrial chemistry. None of it felt adequate. In the early hours of November 7th, a joint working group cross-referenced all the data: light, magnetic, spectral and plasma. A quiet consensus emerged. Every measurable signal from 3I Atlas followed the same master rhythm. It was behaving like a closed-loop system, an entity with feedback, input and regulation. In engineering terms, that describes only one thing: control. If this was true, then the question shifted from what it was to why it was doing this. The sun offered no refuge, no stable point for rest, yet the object seemed determined to remain near perihelion, holding position inside one of the most hostile environments imaginable. Ground-based monitoring at Mauna Kea and Atacama took over as daylight reached Europe, giving the first uninterrupted 24-hour stream of data on the object's new rhythm. The combined light and magnetic curves now showed a pattern too stable to be a coincidence. Each pulse began with a microscopic redshift, a transient dip in surface temperature, and a corresponding magnetic spike that propagated outward through the solar wind. After 27 minutes, the sequence repeated. When analysts overlaid the cycles from different observatories, they aligned to the second. It was a clock. Whatever governed 3I Atlas was operating on a fixed temporal sequence. This temporal precision forced a radical rethink. The only natural structures known to generate periodic electromagnetic output at such intervals were pulsars or magnetars, collapsed stellar remnants far larger and orders of magnitude more energetic than a small interstellar body. Nothing about 3I Atlas matched those categories, yet its emissions displayed coherence, the same physical hallmark that allows stable oscillators and artificial transmitters to exist. The object was not broadcasting in any intelligible sense, but its internal process obeyed a cadence that suggested coordination. At Goddard, a team cross-correlated the hydrogen line bursts with solar wind density maps. To their astonishment, the intensity of each emission adjusted subtly to the background plasma environment, almost as if compensating for interference. That feedback hinted at measurement and correction, a behaviour implying awareness of its surroundings at least on a physical level. In engineering terms, the system behaved like a closed-loop regulator maintaining equilibrium inside a turbulent medium. A second surprise came from the Parker Solar Probe. As it swept through a region downstream of the object's magnetic wake, its instruments recorded a thin, layered sheet of plasma with reversed polarity, something like a boundary separating two fields. Within that sheet, particle velocities dropped sharply, as though energy had been absorbed rather than scattered. It was the first tangible evidence that 3I Atlas was interacting with the solar field through structured containment, not random exchange. Speculation grew that the object might possess a magnetoplasma envelope, perhaps created by the induction of solar energy along conductive materials. If so, it could use that envelope to generate drag or lift within the sun's magnetosphere, explaining both its slowdown and its stability. Such a mechanism, though unprecedented in nature, would parallel theoretical propulsion models once proposed for interstellar deceleration, concepts humanity had never built, only simulated. By the afternoon of November 7th, internal bulletins circulated through NASA and ESA networks under the label Dynamic Magnetic Modulation. The wording was cautious, but the implications were not. If the process was self-regulating, it meant 3i Atlas had crossed a physical threshold, an object demonstrating sustained, patterned interaction with a star's magnetic field. That single fact blurred the line between natural motion and controlled behaviour. Outside the labs, the information remained tightly contained. Press briefings spoke only of unusual photometric behaviour and unexpected deceleration signatures. The full datasets were embargoed while verification continued. Yet within research channels, unease was spreading. Every new line of evidence, thermal constancy, harmonic light pulses, phase-locked magnetic waves, pointed toward organisation rather than chaos. One senior analyst summed it up in a private message later leaked to colleagues. "We are not looking at an object adapting to physics. We are looking at physics adapting around the object. And as night fell over Hawaii, telescopes once again locked onto the dim, steady point near the solar limb. The rhythm continued, unchanged, as if indifferent to the confusion it had caused. A pulse repeating somewhere between energy and intent, leaving humanity to decide which of the two it was watching. In the early hours of November 8th, the data no longer looked like data. It looked like behaviour. The periodic cycles of light, magnetism and motion were too synchronised, too resilient, and too deliberate to be dismissed as a coincidence of physics. Every system that observed 3i Atlas, from solar telescopes to magnetometers, reported the same rhythm, unaffected by distance or interference. The object, now hovering just inside the Sun's gravitational comfort zone, was maintaining a velocity that should have been impossible for any passive body. At the Harvard-Smithsonian Command Center, a silent consensus began to take shape. The equations describing orbital decay, magnetic drag, and thermal flux had all been exhausted. There were no remaining natural mechanisms left to test. What they were witnessing didn't violate physics. It simply operated on principles that physics hadn't yet defined. The deceleration appeared self-adjusting, not constant, increasing slightly as the sun's flux rose, then easing when solar wind intensity fell. The precision of that balance was breathtaking. Parker Solar Probe's latest transmission provided the breakthrough clue. Its onboard magnetometer recorded a sudden drop in local turbulence when it passed through a region trailing 3i Atlas's magnetic wake. The plasma there was ordered, arranged into thin concentric layers that reflected electromagnetic waves in predictable intervals. It was as if the object had created a shell of organised plasma around itself, shielding it from the chaotic environment. That kind of field coherence had never been observed outside controlled laboratory fusion experiments. Engineers reviewing the data realised something extraordinary. The structure around 3i Atlas was behaving like a magnetic sail, a configuration capable of generating thrust or drag purely from its interaction with charged particles. In theory, such a sail could decelerate an interstellar craft without fuel, using the solar wind itself as resistance. In practice, humanity had never built one large or strong enough to test. Yet 3i Atlas, hundreds of millions of kilometres away, was demonstrating that exact behaviour in real time. Within hours, agencies began restricting data access. The public feeds from the Solar and Heliospheric Observatory went dark under the justification of data synchronization. Internal memos circulated referencing the need to prevent premature speculation. But among the scientists still granted clearance, one conclusion became difficult to avoid. 3i Atlas was exhibiting intentional control of its motion. Whether through design or intrinsic physical properties, it was navigating the solar environment, not merely enduring it. The hydrogen line emissions added a final unsettling dimension. When the emission spikes were converted into waveform representations, analysts found amplitude modulations repeating in binary intervals. Not a message, not data, but structure. The kind of structure that only arises from a system that counts, measures, and adjusts. Each pulse contained harmonics, nested within harmonics, like a feedback signal tuned to its own resonance. As evening fell across North America, the observatories logged one final event before the sun's glare obscured the object, a faint but measurable shift in orientation. 3i Atlas tilted just slightly, relative to its orbital plane, a manoeuvre subtle enough to escape public notice, but clear enough for those tracking it in infrared. The change in angle matched a reduction in deceleration. the object seemed to be stabilizing. For the team still awake, the realization came quietly. After weeks of observation, what they had thought was a body responding to solar forces now appeared to be a body using them. The slowdown wasn't resistance, it was positioning, a controlled insertion into a solar orbit of remarkable precision. No one could yet say why or for how long it would remain there, but one fact had become impossible to ignore. Something had entered the solar system, slowed itself near the Sun, and decided not to leave. By November 8th, second dawn over Europe, the first coordinated summary reports began moving through encrypted academic channels. None of them used the word control outright, but their phrasing made its presence unmistakable. Non-ballistic modulation, autonomous magnetic equilibrium, self-consistent plasma damping. Every description circled the same truth without naming it. The pattern of 3I Atlas's slowdown, its spectral pulses, and its orientation change formed a complete self-regulating system. At the European Space Operations Centre, analysts reconstructed a three-dimensional model from all available telemetry. What emerged was startlingly coherent. The object's magnetic field wasn't random or axisymmetric. It showed layered polarity zones arranged like nested shells. Each shell oscillated out of phase with the next, creating an interference lattice that repelled incoming charged particles. In effect, 3I Atlas had built itself a pocket of stillness inside the Sun's storm. No comet, asteroid, or fragment of dust could maintain such stability. The Harvard-Smithsonian group cross-checked those findings against Parker Solar Probe's particle readings. The plasma immediately around the object had a lower temperature and a higher density than the surrounding corona, exactly the opposite of what physics would predict. Energy was being drawn inward, stored, and then released in rhythmic bursts synchronized with the deceleration cycles. It resembled a capacitor charging and discharging under controlled load. Goddard's infrared spectrometer added another piece to the puzzle. During each emission interval, the thermal signature shifted towards shorter wavelengths, implying a brief but intense internal energy release. The event lasted seconds, too short for a natural convective process, but consistent with pulsed electromagnetic activity. When the scientists graphed all of these behaviors together, light, magnetism, heat, they found perfect phase alignment. Every system inside 3I Atlas appeared governed by a single master timing source. That discovery brought with it a wave of quiet apprehension. If the synchronization were accidental, it defied probability. If intentional, it implied design, whether mechanical, crystalline, or something altogether foreign. The official position remained strictly descriptive. No assumptions, no anthropocentric language. But the data no longer fit inside the boundaries of natural formation. Late that evening, an internal memorandum circulated between NASA, ESA, and Japan's JA-XA. It summarized 3 working scenarios. A naturally resonant body with extreme magnetic conductivity interacting with solar flux in an unanticipated way. A self-organizing plasma aggregate sustained by the Sun's electromagnetic field. An engineered object employing active magnetic braking to capture into orbit. The last hypothesis carried a caution tag, speculative, do not release. Yet in private correspondence, several senior researchers admitted it fit the evidence best. Outside of official circles, whispers began spreading across amateur astronomy forums as well. Some observers had noticed gaps in public solar imagery, brief intervals when data feeds paused just as 3I Atlas crossed the field of view. The explanations offered, bandwidth, calibration, compression, sounded routine, but the timing was conspicuous. Within 24 hours, hashtags referencing the solar object began trending on independent science blogs, forcing agencies to prepare a carefully worded joint statement. Inside the laboratories, however, attention stayed on one emerging anomaly. Using cross-correlation from multiple satellites, a graduate team at Caltech discovered that each deceleration pulse produced a faint echo, a delayed magnetic wave propagating outward through the solar wind at a fixed velocity. When modelled in 3 dimensions, those echoes formed concentric spirals expanding away from the object, like ripples from a stone dropped into water. The geometry of those spirals matched no known resonance pattern from natural interactions. They looked designed for distribution, not dissipation. If those ripples were signals, they were not meant for Earth. Their spacing and frequency matched conditions optimal for transmission across interplanetary magnetic lines, paths that could, in theory, carry information to distant points in the solar system. Whether intentional or incidental, the implication was the same. 3I Atlas was now communicating with its environment in a measurable, repeatable way. As the data consolidated and instruments recalibrated for another observation cycle, one thought began circulating quietly among the senior physicists involved. If this object had indeed achieved stable orbit around the Sun using field manipulation, then it possessed a mastery of local physics humanity had only theorized. It had arrived, slowed, and adapted perfectly to the most volatile region of our system. And as the Sun rose once more over the observatories of Earth, 3I Atlas remained there, motionless to the human eye, suspended in equilibrium like something waiting. In the following 48 hours, the object's apparent stillness became the centre of every major observatory's agenda. At first glance, 3I Atlas appeared unchanged, a faint, steady reflection embedded just beyond the solar limb, unwavering in brightness or position. But behind the calm image, the numbers told a story that refused to align with any known astrophysical model. The Sun's gravity should have been reclaiming the object, pulling it into a tighter curve or ejecting it outward through slingshot momentum. Instead, the tracking data revealed almost perfect equilibrium. Its heliocentric velocity had fallen to less than a fraction of what was predicted, while its orbital radius remained astonishingly stable. The equations no longer described a body in motion, they described an anchor point. 3I Atlas had stopped accelerating, had stopped falling, and had in effect settled. At NASA's Jet Propulsion Laboratory, orbital engineers performed the calculation 3 times to confirm what they couldn't believe. The residual forces acting on the object were nearly balanced to zero. Solar gravity, radiation pressure, and magnetic drag counteracting each other with surgical precision. If natural, it was a miracle of symmetry. If artificial, it was control. There was no middle ground left between the two. The magnetic environment around it continued to shift subtly, as though fine-tuned in real time. Measurements from the Parker Solar Probe showed tiny phase adjustments every 27 minutes, the same rhythm that had governed its deceleration. Each adjustment compensated for solar wind turbulence, maintaining an exact position relative to the Sun's surface. In human terms, it was station-keeping, the spacefaring equivalent of a vessel holding orbit against current and tide. Harvard's high-frequency spectrograph registered the most peculiar change. The hydrogen line emission, once intermittent, had become continuous but faint, a low steady resonance exactly at 1420 MHz. Not a pulse, not a burst, a tone. The signal carried no modulation or encoded structure, just constancy, as if the object had shifted from communication to calibration. It was an act of persistence rather than message. The European Southern Observatory confirmed that the object's albedo had increased slightly, though without any sign of material shedding or reflection changes. Whatever it was made of, its surface seemed to respond to solar intensity with an adaptability beyond comprehension, brightening subtly when irradiance increased, dimming when it fell. The response was too uniform for any mineral composition known to physics. By now, the international research community had reached an unspoken threshold. Officially, 3I Atlas remained a natural interstellar body exhibiting anomalous non-gravitational behavior. Unofficially, those words had lost meaning. The anomaly was the behavior. Meetings between NASA, ESA, and defense agencies grew tense. The Pentagon's Space Domain Awareness Office quietly requested live access to tracking data, citing strategic awareness. The request was granted, though it only deepened the unease among scientists. What began as an astronomical curiosity was now being treated as an event with implications beyond science, a potential technological presence within the solar system, origin unknown. Internally, the scientific community began to fracture. One faction argued that continued observation would eventually reveal a hidden natural explanation, perhaps a superconductive body or exotic matter fragment capable of interacting with solar fields in unprecedented ways. The other faction countered that the data no longer pointed toward material physics at all. Instead, they saw intention embedded in the sequence: deceleration, stabilization, orientation, each step part of a deliberate process. The evidence supported them in ways that no one wanted to acknowledge. During the final hours of November 8th, An analysis from the Max Planck Institute discovered a pattern in the magnetic ripples propagating outward from 3I Atlas. The ripples weren't random but logarithmically spaced, each wave expanding at a fixed exponential ratio, the kind of precision found in engineered signaling systems, not natural energy diffusion. The question hanging in every lab across 3 continents was no longer what 3I Atlas was, it was what it was waiting for. The data feeds for the moment offered no answer. The object held its position near the Sun, emitting its faint hydrogen line tone, wrapped in a perfectly stable magnetic cocoon. To the instruments observing it, the entire solar system seemed to move around it while it remained fixed, unshaken, unchanging, as if perfectly at home where nothing should survive. And as the telemetry continued to stream in, a quiet realization settled over every scientist still awake. The object was no longer simply slowing down. It had arrived. The next solar cycle began without warning. A violent coronal mass ejection burst from the Sun's surface late on November 9th, propelling billions of tons of charged plasma directly across the region where 3I Atlas had parked. It should have ended the debate in an instant. No known structure, natural or artificial, could endure that proximity without vaporization, or at least being flung off course. But the CME hit, and the object didn't move. Solar Orbiter's cameras caught the entire event. For nearly 8 minutes, plasma ribbons surged outward, their temperature exceeding 1,000,000 Kelvin. Every other particle trace in the sector twisted violently, except the small point of light that remained frozen inside the expanding wave. Instruments registered a brief dimming, followed by a perfect return to baseline brightness. The magnetic field around the object surged, absorbed, and then inverted, redirecting the coronal stream like a deflected tide. It didn't resist the storm, it used it. At Harvard and ESA headquarters, the data caused an immediate suspension of standard models. The CME should have imparted measurable kinetic energy, altering trajectory or spin, yet neither changed. Analysts concluded that the object had somehow converted the incoming plasma energy into stabilization, as though its magnetic envelope flexed to absorb impact. When visualized as field lines, the motion resembled a ripple traveling inward, collapsing to the center and re-emerging in perfect symmetry. The Parker Solar Probe, positioned downstream, recorded the after effect, a faint electromagnetic echo spreading outward in concentric rings, carrying a frequency identical to 3I Atlas's continuous hydrogen line tone. The resonance had modulated itself during the event, rising by a fraction of a hertz, the first measurable change since the slowdown began. Whether accidental or deliberate, it indicated responsiveness. The object wasn't merely enduring solar activity, it was interacting with it, adjusting itself moment by moment. NASA's Goddard Group proposed the first comprehensive interpretation. 3I Atlas appeared to operate as a self-sustaining magnetic induction system, extracting stability directly from the Sun's own field dynamics. It was neither passive nor mechanical in the conventional sense. It behaved like a process, a phenomenon that existed in equilibrium with its surroundings. The distinction was subtle but profound. What everyone had assumed to be a discrete object might instead be a field-based entity, one whose physical boundaries were secondary to its energy structure. In Geneva, astrophysicists working with CERN's theoretical division attempted to model the energy transformation ratio seen during the CME impact. Their equations suggested that 3I Atlas's envelope had momentarily generated negative magnetic permeability, a condition where magnetic field lines bend opposite to normal matter. Such a state had only ever been produced briefly, inside laboratory metamaterials. If the readings were accurate, 3I Atlas was manipulating magnetism at a quantum structural level, altering the very way space responded around it. Meanwhile, ground-based observers detected something visually subtle but deeply unsettling. Following the solar event, 3I Atlas appeared fractionally brighter and fractionally closer. Not enough to trigger alarm, but enough to confirm that the object had adjusted its orbit inward by a measurable degree, perhaps 2,000 kilometers toward the Sun. The move seemed intentional, almost like a test of its own resilience. Across agencies, the debate grew impossible to contain. A minority argued that the object might be a naturally formed plasma confinement region, an electromagnetic fossil left from interstellar turbulence. Others insisted that nature could not account for its adaptive precision. The idea of technology, however alien or ancient, began to sound less like fiction and more like the only remaining fit for the evidence. By midnight UTC, the hydrogen line signal shifted once again. For the first time since monitoring began, it pulsed, 5 distinct bursts evenly spaced, then silence. The tone resumed at a slightly lower amplitude afterward, as if the event had drained some of its stored energy. Analysts replayed the sequence repeatedly, searching for modulation patterns, but the bursts contained no information beyond their perfect symmetry. Still, the fact that it changed at all meant something had happened within the object, something reactive. In press offices, drafts of official statements were rewritten hourly, each version tamer than the last. A remarkable solar interaction event involving interstellar object 3I Atlas became the agreed phrasing. But inside the private calls and encrypted chat threads connecting laboratories across continents, a different phrase had taken hold: quiet, matter-of-fact, and terrifying in its simplicity. It's alive in the field. Whether alive meant biological, mechanical, or simply self-organizing energy, no one could say. But after surviving a direct solar storm and emerging stronger, the question of what 3I Atlas was had given way to a more immediate one: what it might do next, now that it had proven it could endure the sun itself. For the next 2 days, 3I Atlas remained motionless inside the sun's lower magnetic belt, a quiet presence surrounded by turbulence. Its steady brightness became a metronome in the telemetry feeds, unchanging, indifferent, almost serene. Solar physicists expected residual shockwaves from the coronal mass ejection to nudge it, to leave at least a trace of displacement. Nothing happened. The only activity came from within, the faint hydrogen line tone continuing at a slightly lower frequency, as though the object were cooling or recalibrating itself after the event. By November 11th, analysis teams began looking backward through months of data. They found that 3I Atlas's rhythm, its 27-minute cycle, was not unique. It matched the periodicity of a minor oscillation in the sun's own magnetic field, a wave pattern that had been recorded but largely ignored for years because of its weakness. The object's pulse and the sun's pulse were resonating. Whether coincidence or synchronization, the result was profound. 3I Atlas had tuned itself to the solar heart. At Goddard, engineers tested the idea that it might be absorbing and re-emitting solar energy at that rhythm to maintain its orbit. Their models showed that if a structure could alter its magnetic permeability precisely at those intervals, it could generate a counterforce strong enough to neutralize gravity's pull without expending fuel. In essence, it could float inside a star's magnetic field. The calculation worked perfectly on paper, but no known material could survive long enough to perform it in reality. Yet there 3I Atlas was, proof that something, or someone, had found a way. When the solar orbiter's ultraviolet sensors reacquired the object, its surrounding plasma sheath looked subtly reorganized. The earlier concentric layers had evolved into a complex grid of intersecting filaments, like a woven mesh of magnetism. Each strand flickered in sequence, spreading energy along lines that crossed and recombined with astonishing regularity. One observer described it as a lattice breathing in time with the sun. The phrase stuck. The European Southern Observatory confirmed the pattern, noting that the grid extended far beyond the object's visible boundary, possibly hundreds of kilometers in every direction. This meant 3I Atlas wasn't simply sitting inside the solar field, it was shaping it, sculpting the local environment into an organized structure. The solar plasma itself was obeying its rhythm. That realization pushed the last remnants of skepticism to the margins. Natural bodies don't organize their surroundings, they erode under them. By the evening of the 11th, a new concern began to form. Magnetic instruments on Earth and in orbit started picking up barely perceptible disturbances matching the object's 27-minute pulse. The fluctuations were infinitesimal, micronanotesla shifts buried deep in background noise, but statistically real. Whatever field process 3I Atlas was sustaining near the sun, its harmonics were propagating outward through the heliosphere. The effect was too weak to cause harm, but strong enough to be measured. The object's rhythm was now part of the solar system's magnetic fabric. The official response was swift. Public data from the Solar and Heliospheric Observatory were once again delayed, citing calibration checks. Observatories received guidance to label the phenomenon as localized magnetohydrodynamic interference. But within the inner circle of researchers, the language grew more candid. If 3i Atlas could imprint its oscillation across interplanetary space, it wasn't just interacting with the Sun, it was communicating through it. The question no longer centered on origin. The debate now revolved around duration. Would it remain stable indefinitely? Could it sustain equilibrium through multiple solar cycles? And if so, what was the endpoint of this process? No one could answer. The models had stopped predicting its behaviour days ago. They now only described it. In the last transmission of the night, Harvard's optical array captured a minute change, a slow dimming, not like a loss of power but a deliberate retreat in luminosity. The object wasn't leaving, it was lowering its signature, fading beneath the glare as though concealing itself from observation. For a few minutes, the hydrogen line tone dropped into silence, then returned softer than before. The silence that followed in control rooms across 3 continents was palpable. Some thought the cycle had ended, others believed it had only just begun. But all agreed on one thing: 3i Atlas was no longer simply a visitor. It had become part of the Sun's own system, integrated into the magnetic rhythm of the star itself, an unknown intelligence, perhaps ancient, perhaps recent, now hidden in plain sight at the centre of everything we thought we understood. By the afternoon of November 7th, the verification process had evolved into something closer to containment. Every observatory involved in monitoring 3i Atlas had confirmed the same figures, yet no one wanted to be the first to declare what those numbers implied. The data were clear. The object's deceleration was not a transient fluctuation. It was sustained, rhythmic, and purposeful in pattern. At Harvard, the telemetry room stayed dim except for the faint glow of monitors, each displaying streams of real-time tracking data. Every few minutes, analysts compared the updated orbital readings against projection models. The result never changed. 3i Atlas was continuing to resist gravitational acceleration. The residual velocity curve had flattened completely, a steady plateau where there should have been a descent. The European Space Operations Centre reached the same conclusion through independent measurement. Their Doppler spectroscopy, refined over several nights, showed near zero drift in radial speed. To eliminate any possibility of instrumentation error, ESA requested confirmation from NASA's Deep Space Network. The radar data returned perfectly aligned with Harvard's optical calculations. The phenomenon was real, and no conventional explanation fit the observations. The tone in internal communications had shifted. Scientists who once described the slowdown as unexpected now called it structured. The word had no official definition in this context, but everyone understood its weight. It meant that the object's behaviour showed coherence, a pattern too deliberate to emerge from random processes. The last serious natural hypothesis, asymmetric mass loss from volatile material, was quietly dismissed earlier that morning. Spectroscopic scans across multiple wavelengths found no trace of gas venting or dust ejection. The light curve remained pristine, without the chaotic signatures typical of sublimation. Whatever was driving the deceleration, it came from within or from interaction at a fundamental level of its environment. At ESA, plasma physicists began testing a new model that described 3i Atlas not as a solid mass, but as a partially conductive structure capable of responding dynamically to solar magnetism. In this view, the object acted like an adaptive sail, adjusting its position and speed by controlling how it coupled with charged particles. The problem was scale. For a body of this size and mass, the required field strength would exceed any naturally occurring material by orders of magnitude. Yet the math held perfectly if one assumed the process was deliberate. Meanwhile, the Solar Orbiter team released updated magnetometer readings that hinted at periodic alignment between the object's light variations and local magnetic disturbances. Every 27 minutes, faint oscillations appeared in the surrounding plasma, weak but measurable, repeating with precision. The synchronization was uncanny. Some scientists described it as resonance, others simply called it feedback. Harvard's internal bulletin summarized the situation in restrained terms. Object 3i Atlas demonstrates non-gravitational deceleration consistent across independent observation platforms. No thermal, mechanical, or optical phenomena consistent with known propulsion or natural drag mechanisms have been detected. Continuous monitoring recommended, but beneath the formality, unease was building. For decades, interstellar visitors like Oumuamua and Borisov had at least fit inside the boundaries of physical explanation. 3i Atlas didn't. It was maintaining an energy balance impossible to reproduce on Earth, stable, deliberate, and apparently self-regulating. One analyst, writing in an encrypted chat used for after-hours discussion, summarized what many were thinking but none would publish. If the slowdown is active, it means it's responding to something. Maybe to us, maybe to the sun. Either way, it's listening. By the end of the day, every observatory watching 3i Atlas agreed on one point. The anomaly had entered a new stage. It was no longer accelerating or decelerating in the expected sense. It was holding. The interstellar visitor had reached a point of balance that defied celestial mechanics, and for the first time since its discovery, the question among researchers was no longer whether the object was natural or artificial, but whether they were observing it, or if, in some way, it was observing back. By the evening of November the 7th, the international science networks were saturated with a single dataset, the stabilization curve of 3i Atlas. The curve no longer looked like a trajectory, it looked like a pulse that had found equilibrium. For 40 consecutive hours, the velocity readings had barely shifted, holding within margins smaller than any previous deep space measurement error. The effect was so precise that some engineers began checking whether their software had locked a constant variable by mistake. It hadn't. The object itself was maintaining that stillness. At Harvard's Center for Astrophysics, the analysts tried to model what a self-correcting system in space would require. The numbers were unreal. Any mechanism capable of opposing solar gravity with this accuracy would need to sense flux changes faster than any known magnetometer and respond in milliseconds. The algorithms they built to simulate such behavior behaved more like control loops than celestial mechanics: feedback, correction, equilibrium. On paper, 3i Atlas moved like a stabilized platform, not a drifting rock. The European Southern Observatory reached a similar conclusion from its optical logs. When they mapped microchanges in brightness, the pattern resembled a heartbeat. Small rises and falls repeating at fixed intervals, synchronized with those same 27-minute magnetic oscillations. It wasn't a perfect sine wave, it carried subtle distortions, as if reacting to external turbulence. But the consistency was undeniable. Each pulse corresponded to a magnetic microburst and a faint shift in spectral absorption. Light, magnetism, and motion all moved together as one system. By now, the word feedback had become a quiet refrain in every private meeting. It described everything they saw, but explained nothing. If 3i Atlas was adjusting its own state in real time, it meant the forces acting on it were being measured and counted moment by moment. That would require not only sensitivity but intent, physical or algorithmic. At NASA's Goddard Space Flight Center, the thermal team pushed a different angle. They focused on the steady infrared emission that had puzzled observers for weeks. When they overlaid temperature data against solar wind density, they noticed the emissions dipped each time a plasma stream intensified, then recovered when the stream eased. The object wasn't heating from the solar wind, it was responding to it, lowering its output as if conserving balance. The signature looked like regulation. A small group within ESA began exploring a radical hypothesis, that 3i Atlas might not be a solid object at all but a cohesive field phenomenon, a structure of plasma stabilized by electromagnetic tension rather than matter. If correct, it would behave as both an object and a process, capable of interacting with magnetic pressure the way a sail interacts with wind. The model predicted exactly the kind of slowdown now being observed, but only if the phenomenon could adjust itself continuously, like a living circuit. Late that night, a secure transatlantic call linked Harvard, ESA and JPL for what was supposed to be a technical review. It quickly turned philosophical. The participants debated whether a naturally forming plasma structure could exhibit self-correcting feedback without collapsing. One of the younger researchers finally broke the silence. Then maybe it's not a structure that formed, maybe it's one that arrived. No one answered. The call ended with an agreement to classify all further discussion of non-natural models as speculative. Outside the official channels, the tone had changed. Observatory teams weren't talking about trajectories anymore, they were talking about behaviour. The object's deceleration had become background, the new focus was its persistence. It was as if 3i Atlas had reached the exact state it wanted and decided to hold it, ignoring every external disturbance. As midnight approached on the east coast, the latest light curve data came in. Perfectly stable, amplitude unchanged, frequency unchanged, no rotation detectable. In the quiet hum of computer fans, one analyst looked at the unbroken flat line across his monitor and murmured what many now felt but wouldn't write down. It stopped because it can. And somewhere near the inner orbit of Mercury, still invisible to the naked eye but pulsing faintly in every instrument tuned to it, 3I Atlas continued to hold position, motionless against the pull of the sun, suspended between gravity and will. By the early hours of November 7th's final observation window, the data flow from every major observatory began to settle into the same strange pattern. Nothing was changing. No measurable acceleration, no drift, no variation in luminosity beyond instrumental noise. 3I Atlas had reached a state that should not exist. A stable pause in a place where physics allows only motion. Inside Harvard's telemetry control room, the atmosphere was a mix of exhaustion and disbelief. Analysts had begun rotating in 12-hour shifts, yet the numbers refused to move. The residual forces that should have dictated the object's fall into the sun's deeper gravity well were balanced to within 1 part in a million. Even accounting for magnetic pressure, solar radiation, and wind turbulence, there was no scenario where a passive body could remain fixed like this. The models were complete, the error bars were gone. The ESA coordination desk in Darmstadt confirmed the same reading. When they compared magnetic field fluctuations around the object to baseline solar activity, they noticed that 3I Atlas was damping local turbulence. Instead of being buffeted by the solar wind, it was smoothing it, absorbing and releasing plasma energy in patterns that reduce chaos around it. The plasma environment immediately surrounding the object had become quieter than the space beyond it. That kind of stabilizing effect had only ever been theorized for active magnetic containment systems. NASA's Goddard group checked the data again, expecting a glitch, but the field coherence held across instruments. The magnetic vectors formed concentric alignments around the object, like ripples that refused to fade. When plotted in 3 dimensions, the pattern resembled a lattice of nested rings, rotating imperceptibly, each compensating for the other's disturbance. The structure looked engineered, though no one dared use that word in the official documentation. A memo circulated just before dawn, summarizing the day's findings in careful language. 3I Atlas remained stationary relative to heliocentric reference frame within current measurement limits. Surrounding plasma shows reduced turbulence, suggesting energy transfer consistent with field-mediated stabilization. Continued observation recommended. No causal model verified. Behind that restraint was quiet awe. Some researchers compared the phenomenon to a magnetic mirror used in fusion experiments, a self-contained reaction balancing inflow and outflow perfectly. If that analogy were accurate, it meant 3I Atlas was not defying gravity, it was negotiating with it. In private logs, a few scientists wrote what they couldn't publish, that perhaps the object was not an intruder at all, but something responding to the sun as if returning to a familiar resonance. The 27-minute oscillation, the rhythmic modulation of light and magnetism, even the measured field damping, all of it aligned with subtle periodicities in the sun's own outer layers. The possibility arose that 3I Atlas was synchronizing, not resisting, a participant rather than an outsider. As the sun's edge brightened for another morning pass, the data feeds continued their steady hum. Instruments recorded the same heartbeat, light dip, magnetic pulse, thermal correction, silence, over and over without deviation. The pattern had become so stable that engineers began using it as a calibration reference for their equipment. What had begun as an anomaly was now a clock. No one could say how long the balance would last, or whether it represented an endpoint or the beginning of a new phase. But for now, on this exact date, November the 7th, 2025, the object known as 3I Atlas sat fixed in the solar field, quiet, precise, and unyielding. It neither approached nor retreated, neither burned nor cooled. It simply existed, perfectly poised between the pull of the sun and the mystery of its own restraint. At this hour on November 7th, 2025, every active observatory continues to record the same impossible stillness. 3I Atlas remains locked near the inner boundary of the solar field, suspended inside the brightness of the corona. Nothing in the last 6 hours suggests motion. only subtle adjustments in the surrounding plasma, as if the space around it breathes while the object itself does not. At Harvard-Smithsonian, the control room screens show one constant line of telemetry: position steady, velocity steady, brightness steady. The analysts whisper instead of speak. Each update carries the same annotation, no change. They run diagnostics, recalibrate spectrometers, even rotate antennas to different frequencies, but every instrument reports the same truth: the object is fixed. Solar orbiter's magnetic sensors confirm that microdisturbances continue to pulse outward every 27 minutes, faint enough to vanish into background noise yet consistent enough to mark a cycle. ESA technicians debate whether those pulses come from internal oscillation or from resonance with solar magnetic waves already present in the corona. No conclusion is possible. The data are too precise for chance. At NASA's Goddard facility, infrared arrays detect no heat fluctuations at all. The readings hold to within 1/10 of a Kelvin, a stability that would be remarkable even for a ground-based cryogenic system. The scientist on duty notes in the log that the spectrum appears frozen, an equilibrium between absorption and emission unlike anything seen from natural material. The description is clinical, but her handwriting wavers. Across agencies, engineers are now testing whether the apparent immobility might be an illusion, a trick of light caused by the sun's rotation or by delayed telemetry through dense plasma. But triangulation from 3 vantage points, Earth, Solar Orbiter, and Parker Probe, removes that possibility. All lines of observation converge on the same coordinates. 3i Atlas is exactly where it was yesterday, down to the kilometre. Internal chat threads circulate among senior physicists as the night deepens. Someone posts a short remark that draws no official reply but remains visible in the record. If it isn't moving, then it's maintaining itself. No one disagrees. For the moment, the teams do not know what that maintenance means: field stability, structural integrity, or deliberate control. They only know that the slowdown has reached its limit. The interstellar visitor that should have passed the sun and vanished into darkness has stopped, and as of this exact minute, November the 7th, 2025, it holds its place against a star that never stops moving. At the Harvard-Smithsonian lab, the data screens glow pale in the low light of early morning, November 7th, 2025. The numbers have stabilized completely. Every known instrument confirms it. 3i Atlas is not accelerating, not drifting, not reacting. It has settled into an unchanging balance inside the solar field. With motion halted, the conversation shifts from verification to context. By late morning, researchers begin reaching backward through archives of similar mysteries. Files once stored as footnotes: Oumuamua in 2017, Comet Borisov in 2019, the 2020 interstellar fragments detected by the Subaru survey, are reopened line by line. These events, once considered isolated, are now being studied through the lens of what is happening right now. The comparison begins quietly. Oumuamua had shown a small, unexplained acceleration away from the sun, later attributed to outgassing that no telescope ever actually detected. Borisov behaved normally. Nothing since had exhibited such strong non-gravitational behaviour until 3i Atlas. The difference noted across every private call and report is precision. Oumuamua's motion was erratic. 3i Atlas's motion is measured, timed, symmetrical. ESA's review board cross-references magnetic readings from that earlier object. In 2017, background solar data had been too sparse to reveal whether magnetic resonance was present. Now, with modern solar observatories running continuously, the contrast is clear. 3i Atlas's environment is organised. The magnetic field near it is structured, not random. There are layers, periodic ripples, the same rhythm repeating throughout the day. The scientists can now see what older instruments would have missed. At Caltech, an astrophysicist who once studied Oumuamua describes the difference this way: "That one left, this one is staying." He's speaking to a colleague off record, but his words circulate anyway. The phrase becomes shorthand for the new problem: the permanence of an interstellar object in solar orbit, something that by every definition should be impossible. The Harvard group begins constructing an internal timeline showing the sequence of human encounters with such anomalies. From 1947 radar returns that hinted at transsolar debris, to the 1990s reports of high-velocity interstellar meteors later confirmed by trajectory reconstruction. In every case, The pattern had been transit. Objects entering and leaving, none had ever lingered. The timeline stops abruptly with today's entry. November the 7th, 2025, velocity stable. Goddard's plasma team contributes a small note that passes through every agency inbox by midday. Subject exhibits self-consistent modulation and sustained stationing behavior. Historical precedent. None. That line becomes the heart of every classified summary that follows. It confirms what the data already make obvious. This event does not belong in the catalogue of previous interstellar visitors. As the day goes on, observatories in both hemispheres continue to confirm the same findings. 3i Atlas remains locked in its solar position. There are no measurable changes, no emissions beyond the faint hydrogen line, no debris. The object, if it can be called that, has ceased acting like a traveller and begun acting like a fixture. By evening, researchers stop speaking in terms of trajectory altogether. They call it the position, as though referring to a landmark. The shift in vocabulary is subtle but profound. For the first time, scientists describe an interstellar visitor not by where it's going, but by where it is. As of this hour, November the 7th, 2025, that is all anyone can confirm. The object once moving through the solar system now holds steady near the Sun. Every theory that explains motion has failed to explain stillness, and so the investigation continues, one step further from precedent, one step closer to whatever unknown principle 3i Atlas represents. By the late hours of November the 7th, 2025, the word precedent has lost all practical meaning. Every attempt to categorize 3i Atlas by historical analogy ends in contradiction. In the archives there are stories of fragments, comets, cosmic dust, and erratic travellers, but nothing that fits what the instruments are recording tonight. A body from outside the solar system that has stopped, balanced within the furnace of the Sun's magnetic field, neither consumed nor expelled. The review boards now turn to comparison not for explanation, but for limits. Oumuamua's brief acceleration could be modelled within error bars. Borisov obeyed every known rule. Even the high-velocity meteor CNEOS 2014-0108, confirmed as interstellar, followed ballistic expectations. 3i Atlas violates them all. The data flowing across agency servers show no mass loss, no spin drift, no chaotic torque. Its energy state is steady, as if every external influence is being measured and counted the instant it appears. At Harvard, a small team reruns the earliest discovery images from months ago, stacking them against today's telemetry. They find a faint but traceable pattern. The deceleration curve began long before the object reached perihelion. It didn't slow at the Sun, it had been adjusting all along. The realization spreads quietly. Whatever is happening now was not triggered by the solar encounter, it was the destination. Yissa's plasma division compiles a cross-reference of all previous anomalies near the Sun, magnetic mirroring events, transient field collapses, solar sail experiments, and one entry stands out. In 1998, a brief signal at 1420 MHz, the hydrogen line, had been detected by the WIND spacecraft, dismissed as interference. The pattern of its sideband harmonics matches, within error, the present emissions from 3i Atlas. The note circulates privately, marked unverified correlation. At Goddard, the senior thermal engineer writes in her daily log that the stability of the object's emission has reached the limit of her instruments. She adds a single sentence that none of her colleagues erase. If this is equilibrium, it's intelligent equilibrium. The phrase stays in the record because no one can replace it with something better. Meanwhile, Solar Orbiter's magnetometer continues to pick up the regular pulses at 27-minute intervals. The amplitude has not changed since the previous night, but now the surrounding solar plasma seems to respond. Faint synchronizations, ripples aligning to the same rhythm. The phenomenon might be coincidence, yet it repeats often enough to look intentional. Observers describe the effect as entrainment, a word normally used for biological systems that fall into step with external stimuli. Here, it applies to a star. Inside ESA's data coordination room, an analyst posts a summary line that will appear in several reports by morning. No physical precedent, behavioural precedent uncertain. The cautious phrasing captures the atmosphere perfectly. The science remains disciplined, the tone measured, but beneath the surface the implications are impossible to ignore. If 3i Atlas is influencing local solar conditions, even slightly, Then it has crossed from being an object of observation to a participant in the Sun's own environment. And so, as November 7th draws to a close, the world's observatories continue to watch the same unchanging point of light. The data are calm, the instruments steady, the Sun itself roaring quietly around it. No announcement is made, no conclusion written. For now, every scientist involved agrees on a single fact. The phenomenon is ongoing. What it means will be decided later, but tonight, on this exact date, 3I Atlas holds its place inside the east in the final hours of November 7th, 2025. The rhythm continues, steady, precise, and indifferent to the attention it commands. The telemetry streams have become so predictable that software once written to analyze anomalies now serves only to confirm constancy. The latest packet from Solar Orbiter arrives 6 minutes early because of improved relay timing, and still, every number matches. The object's position, velocity, magnetic oscillation period, and temperature hold within the same infinitesimal margins that have defined the entire day. At Harvard, no one uses the word stationary anymore. It carries implications that science isn't ready to adopt. Instead, the team calls it steady phase. The phrase appears in the nightly summary, written by the project coordinator at 2347 UTC. Steady phase conditions persist. No evidence of rotation or emission variability. Local plasma environment remains stabilized within measurement limits. It is the calmest sentence in the file, but also the most extraordinary. Nothing in the known solar system remains that stable, not even the instruments observing it. ESA's main server compiles the global log into a single shared dashboard. 29 observatories contribute real-time input, and all 29 show the same unbroken symmetry. Across Europe, the scientists begin shutting down their auxiliary sensors, conserving power for long-term observation. The event is no longer a chase, it is maintenance, human patience against inhuman stillness. At Goddard, the thermal team begins plotting microvariations in the solar wind near 3I Atlas's coordinates. The data reveal a narrow corridor of suppressed turbulence extending outward from the object. It resembles a wake, except nothing is moving. The plasma directly behind the object is calmer than plasma farther away, suggesting that the region itself is being shaped, guided into equilibrium. The Sun's chaos bends gently around it. By now, the scientists have run out of synonyms for unknown. They start labeling variables alphabetically, A for energy absorption, B for field emission, C for plasma interference, none of which fit into any conventional model. The energy equations balance only when a new term, D, is added to represent an internal regulator. They don't define D, they just leave it in place as if the universe has inserted a correction factor no one can name. Minutes before midnight, Harvard's radio telescope array completes its final cycle of the day. The hydrogen line tone remains constant, but embedded in the baseline noise is a subtle harmonic rise, a faint secondary frequency separated by exactly 27.001 minutes. It could be interference, a reflection, or just coincidence, but it aligns perfectly with the timing of the magnetic pulses. The analysts note it, but no one comments. The discoveries entered into the log, time-stamped, and archived. Elsewhere, the skies over Mauna Kea are clear. The object, barely distinguishable through filtered optics, appears motionless against the solar glare, a fixed grain of dark gold near the edge of perception. Observers describe the sight not as luminous, but as present, a point that should not be there yet refuses to vanish. As the final transmissions of the night are compiled into one global archive, the lead coordinator drafts the closing line for the official day's record. November 7th, 2025. Object remains in gravitational equilibrium. All indicators constant. Cause undetermined, that line will circulate across agencies by morning, but as of this moment it is still just data, silent, unembellished, alive on screens in empty rooms. The sun continues to burn, the field hums, and 3I Atlas holds its place inside it, still as ever. The day ends exactly as it began, with the universe refusing to explain itself. By the final hours of November 7th, the world's leading institutions have stopped questioning what happened. The focus now is how. If 3I Atlas is holding position against the sun's gravity, there must be a mechanism, a process that balances forces so precisely it escapes current definitions of motion. The problem is that none of the candidates survive mathematical testing for more than a few lines. At Harvard-Smithsonian, plasma physicists attempt the simplest explanation first: magnetic drag. They simulate a conductive body interacting with the sun's rotating field, generating current loops strong enough to counter acceleration. But the required conductivity would demand material that behaves like a superconductor at millions of degrees, something that should not exist outside theoretical models. ESA's magnetic systems team explores the idea of self-induced stabilization. In their model, 3I Atlas is not passively sitting inside the solar wind, it's feeding on it, absorbing the momentum of charged particles, converting that energy into resistance. The simulation fits the slowdown curve perfectly, but it requires real-time regulation, a feedback mechanism that senses and reacts faster than any known physical process. It's elegant in math, impossible in reality. At NASA's Goddard Center, thermal specialists test a counter-hypothesis. Perhaps the object is less a structure and more a field, a plasma construct bound by electromagnetic tension, forming a coherent surface without solid matter. If true, it could explain both the uniform temperature and the absence of outgassing. Yet, even in that model, a stabilizing core would be needed to maintain symmetry under solar pressure. No one can describe what that core could be. Throughout the evening, encrypted conference lines carry these ideas back and forth. No one claims certainty. Every suggestion folds under its own contradictions. Still, the discussions continue, because silence would mean admitting they have no framework left. At 23:59 UTC, a brief note is added to the consolidated log, short, unadorned, and unsigned. The anomaly may represent an unrecognized class of interstellar system, one capable of dynamic field interaction. Its persistence implies self-sustainment. Mechanism unknown. That single entry becomes the day's final sentence in every agency report. It is both conclusion and confession. As November 7th, 2025 draws to a close, the universe feels momentarily paused. The sun, vast and ancient, burns as it always has, yet within its reach, one object stands perfectly still. For 24 hours, 3I Atlas has shown no drift, no decay, no motion, only a quiet defiance of everything that should move. The observatories dim their lights one by one. Computers keep running through the night, recording silence in numbers. Every data set, every cross-check, every recalibration points to the same outcome: equilibrium. For the first time in human observation, something from beyond our solar system has come here, not to pass through, not to burn, but to remain. No one knows whether it is alive, mechanical, or simply the byproduct of laws we do not yet understand. But as the last entry of the day is written, and the screens fade to standby glow, the sentiment across every lab is the same: it's still there. And for now, that is all the universe is willing to say.